Hi. Um, this is kind of a little meta comment here before the video gets started. I do have a warning. The raw video itself, assuming I don't edit anything out, is about uh, 4 hours and 36 minutes or something like that, almost 5 hours. So this is a pretty long video. You probably don't want to watch through the entire thing. These are some links for you so that you can skip ahead to different parts of the video. Um, and you can also see these listed in the description of the video below. So go ahead and just kind of skip to the parts that you think are interesting. You don't really have to watch the entire video. I know it's really long and tedious and boring, and there's actually a lot of mistakes and a lot of kind of slow going here and there. But I do usually keep those things in just to kind of keep the art of kind of showing everything that I've done. Um, so it's not necessarily the most beautiful thing or the most kind of succinct end all video, but it will contain kind of that information there to kind of show kind of the art or I guess, the challenge or the experience of it, because I believe that the entire coding experience, or the entire experience from planning to coding to all that is kind of important. And you might want to hide some of these things, but actually it's kind of important to minimize or optimize all of these things, even if it's something that's silly or on the side. It's good to view it, because actually I am under the impression, even though most people aren't, I am under the impression that pretty much anything, as long as it takes a lot of time and becomes a costly part of your project, can be optimized, can be reduced somehow. It might be an extremely challenging task to reduce that, and for me, one of these was reducing actually having to use libraries to design software, which sounds crazy, but it's kind of some of the research that I'm doing um, at the moment, or that's kind of inspiring some of the research that I'm working on. So go ahead and just skip to the parts that you find interesting, things that you want to see, and I hope you enjoy. Tetris is a wonderful game. I wish I could have made a better, faster working game, but I was glad that I actually was able to make a colorful one on the calculator. And it's not the best in the world. I complain a lot. I talk about Texas Instruments and all these things, and I was under some stress during part of this. But it's okay. It's all part of the experience and everything like that. You don't have to watch the whole thing. Um, but if you like to, then feel free to. That's kind of what this is for. This is for people who just kind of want to just kick back and relax. Um, you can watch this in parts or whatever you want, but I kind of wanted to keep it all as one video so that you can watch it all together as a group and you don't have to click links and things to find different parts of the video. So, yep, I'm going to try to categorize it for you, and you can just go from there. Have at it. Watch whatever part of this video you want. And that's all I've got to say. This is Tim, and it's been fun coding, and I will see you guys later. Whew, okay, I've been playing with this for a long time. It's probably been like even over an hour or something. I don't know. Um, as you can see, I got all this stuff going on. Pretty much what I wanted to do, because I'm trying to do Tetris, is I wanted to just output I just kind of wanted to output some colors, but I noticed that I can't really do that. Like, I can just output numbers and text, and I'm not in control of what color I'm doing, unless I'm drawing, which drawing I found out is not, there's not very many options. So in the draw menu, I've searched through these a lot, and I noticed that there really isn't anything good for what I'm trying to do. In fact, the only good thing that I know of is just drawing lines. I don't even know how to draw a box. I can't even draw like a box of pixels. It's kind of sad. Yeah, this calculator is like very, very disappointing when it comes to programming. I really thought I was going to be able to program in color. I can't. There's no, like, there's literally no option. It's really frustrating. I really am disappointed. I wish TI, you know, they come and visit University of Illinois. I wish somebody would have, you know, just asked when I mentioned, hey, I program your calculators. Hey, do you have any suggestions? We're making one with color. Oh, yeah, sure. I like coding with, you know, just watch my videos or something, but I guess they don't care, you know. It's not their business. So, anyway, so I've been playing with this a lot. Another thing is I can't even set the window. Like, there's no X min or X max that I can set unless I go to this menu. Like, it's literally, these variables are not in the catalog. I don't know why, but they're not in the catalog. And I think they should be, because then I can set them, but I can't. So I basically have no control over the window size from here, because I want to set it from whatever it's at. It has to be it has to start off at an arbitrary number, and because TI, apparently Texas Instruments, is not very good at recognizing these things, which I don't understand why someone can, like, recognize this. But anyway, yeah, I guess I have to set it to standard first, because I believe standard actually sets the values to, no matter what they start at, it sets it to some constant that won't depend on what it already is. And then quadrant 1 will take this, at least. I don't know if it sets it to a constant, but anyway, obviously it does something to get it to the first quadrant, and then square takes it from whatever it's at, and it does not set it to a constant, which is not implied by it. Kind of implied by its title, but I think it should be explicit by its title. But anyway, square basically just makes it square, and there's nothing in the description about it. The only thing in their description is basically what parameters you need to use for things, which is kind of necessary to use the functions, but they don't have descriptions either, which is kind of also necessary. But anyway, these this 19, 10, 11, 14, these are color numbers that I had to find out by printing them. Thankfully, I'm so glad that I could do that. I thought I was going to have to manually, like, access the colors, but apparently I can actually pass them in, which is nice. That's how it should be. There should actually be a color function that you pass in a number and it returns a color or something like that, but I don't know. I guess this is how it works. I don't know how it recognizes that the parameter is color, because there's a lot of optional parameters for these functions, but it knows it somehow, which is nice. So yeah, I've kind of been playing around. I've been figuring out what I wanted to do, and I guess drawing lines is kind of fast enough for me to attempt to do what I want to do, I think, with Tetris, I believe. So yeah, we're going to kind of copy this program that I've been messing with a little bit, and we're going to create Tetris. And hopefully I can actually, yeah, you know what I'm going to do is I'm going to import test straight into here. There we go. So now we can just work with this. So I clear the drawing screen so that there's nothing there. And I was also doing that because I was trying to zoom fit, but I think it only works on the functions. And then I set the something to the deterministic size so I don't have messed up coordinates. Then I go to quadrant 1 because it's easier to work with that. And then I square it because I want the pieces to be square and to work with x and y with the same kind of coordinates. And then I store a global kind of color scheme that I'm going to be using. Now this 0.9, it's basically the offset for the points that I'm using, because I wanted to be able to scale it how I needed, and I kept having to write that down, so I just put it as O here so that if I need to change it for whatever reason, it'll be easier. So I go from y is 0 to 5 and x is 12 to 16. So these numbers here represent kind of the edges of the window. There will be side boxes that I'm going to set for the edges of the screen. So basically what I'm going to do, and you know what, I'm also going to set another list, and it's going to have these colors like gray, light gray, dark gray, I think. So light gray, medium gray, gray, and dark gray. And the reason why I'm doing that is because it's just going to make a nice looking kind of wall thing. So let's just go ahead and get their numbers. So I'm going to just display 3 times. And I'm just going to get these colors. For some reason their numbers are like weird things, but it doesn't matter. We'll just go with it. And let's go. Okay. Okay, 21, 22, 23, and 24. I didn't know that they would be those numbers, but okay. We're editing Tetris. Okay, 21 through 24. Okay. Okay, and we're going to store that into list 2. And then what we're going to do is down here, we're going to use list 2. Okay, and then x is going to go from 12 to 16. And I kind of don't want to do this. I guess I'm going to have to double the... Yeah. Yeah, so x is going to be -4 to 0, but then -4 plus 16, so I'm going to have to add like 16 to x, and do another set of 4 lines here, I guess. This is why I wish I could store functions. Yeah, that's the thing about TI Basic, is you can't pass functions, so the whole don't repeat yourself thing is almost impossible for simple functions, and you actually do have to repeat yourself a lot, and it gets annoying. But I guess I should limit how much I make fun of the people who work at TI, because I guess it just won't get anyone anywhere, because people in this world don't like to always see things for what they are, and telling them that sometimes just simply doesn't help. I don't know why. I love being corrected, but I guess some people just, I don't know. They think that if somebody believes that they're right, then that's what makes them right, rather than actually being right. So x plus O plus 16. Yes, I'm adding 16 to each one. It's sad. I know. I'm sorry. I would not do this if I had a choice. I do not like the basic programming language, by the way. I always liked programming in this, in the calculator and stuff, but yeah, it's not the best language ever. Just saying. But still, we're gonna make something cool and pretty, so let's do that. Let's test this out. See if it does what I wanted it to do, and it looks like it does. Kind of. It's not going all the way up. And why is my calculator, or my screen is getting blurry? It's losing its zoom. So the Y should go, I think, to 16 then, because if the X it's still going. How many is that? I don't know how many let's run that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Okay. So 13. Or 12. So there we go. 2, 3. There we go. Okay. That seems about right. Yep. So that kind of, those will be like our walls that we play in, I guess. We could scale it maybe, but I don't even know how. Like, I want to set the window to be like 0 to 13. Like Y max. I don't know how to set Y max from within my program. And that's kind of annoying. Like, how do I set Y max here? You know what I mean? Like, how do I set it? I don't want to set it here. I want to set it in the program automatically. That's how I write my programs. I write them to handle whatever the state is of the calculator. Before you run the program, it works no matter what. My programs don't depend on the state of the calculator. That's kind of how I like them to work. And I can't do that unless I just go with some whatever Z standard is, because I can't even set it here. Like these 1/8, these don't give me integer numbers. It doesn't work. I don't know what's wrong. I don't know. See, like Z decimal, no arguments. Like none of these take arguments. That's so bad. It's so bad. I'm sorry, Texas Instruments. It's so bad. It's so horrible. I would not program a calculator like this, but then again, I'm not Texas Instruments. Okay, so let's see, what are we doing next? They did a lot of things nice. There's a lot of cool things. It's better than no calculator at all. We'll put it that way. Let's look on the bright side. There exists a calculator such that it does something more interesting than just a pocket of air. So here we go. Let's see. We did that. Now we want to pick a random piece, I guess. and we're going to put it somewhere kind of on the screen, and it's going to fall until it hits the ground. And when it hits the ground, we're going to save it. So we have to have a matrix. So we have to have. So what we're going to do is we're going to have an offset for x. That's going to be 4. So every time we output our x, it's going to be 4. And yeah. Yep, that's how it's going to work. Sure. Let's do that. So let's pick a number. So how are we going to do this? Well, okay, let's not even do a loop yet. Let's just draw something on the screen where the starting piece should go. So let's do like let's pick like a 4x4 kind of square. Well, it doesn't need to be a 4x4, but it needs to be like a 3x4. No, it needs to be a 2x4. Because all pieces can fit into 2x4 space. Right. Okay, so okay, let's put it in like the middle as much as possible. So kind of let's look at this. So how many spaces are there in the middle there? 12? Maybe? Is it? Or am I counting this wrong? Am I doing this wrong? Because, I plotted 5 on each side, so it's thinner. So if that's 13 tall, then the center is going to be like 11 wide. So let's put it like 5 in or something, I guess, at the top. Yeah, let's figure this out. So let's draw. Let's have 4. Let's use lists. I guess lists 4 and 5 for the coordinates. So list. So 0. So okay. Y. Okay, this is what we're going to do. We're going to have a for loop. For A is 1 to 4. And what we're going to do... Oh my goodness, this is crazy. We're going to pick a random int from 1 to 4 and store it to R, and we're going to store a new C from L1. Okay, so random int from 1 to 4 stores R, and then L1 of C stores C. No, L1 of R stores C. So that will give us a random color. And now we need a color based on each of the list of A. So L4 is going to be our x's, right? Yeah. So L4 of A, that's going to be like our x. Oh, this is confusing. Okay. So that is going to go to y. Okay, so we start with our offset of x. Right. Okay. So we start off with this. And then C is going to be our color. Okay, so we need 4 of these lines, because each of these is going to draw a box, and then there's going to be 4 boxes. So L4 of A plus 0 plus O. Now we need to go the other direction, which means we're going to add O to the other one. I wanted to do it like I did it another way before, and then I tried to get rid of a pixel, and that's why it's like, that's why it goes like in a box shape instead of like the way I did it before. Anyway, so then this one is going to go to, no, that's what it's going to go to. So then L4A plus O, and then L5 of A plus O. And then here it's going to be L4A plus O, comma L5A plus O. And then we're going to go down a notch to, we're going to take the L4 down a notch, L4 of A, and then L5A plus O. And then the next one's going to be L4 of A L5A plus O, and then L4 and L5. Yep. So that's it. That's that. Now we need to store L4 and L5. So the coordinates, so X is going to go, so, oh, and here's another thing. I need to add 4 to the X, right? I need to add 4 to the X. And you know what? I'll do it down here. So X is going to be offset by, I don't know, we'll call it Z. So 4 stores Z. Or we'll say 5 stores Z. So right now the width of our game is 5. Or the width of the margin on the walls is 5. And I want this to be a variable because anything with that we have to put in the coordinates is just too much to go and change later. So I want it to be a variable so that we can, if we need to mess with it. So X is the first one, yeah. So I'm gonna add Z to all of the X's, all of them, as we plot it. It'll always happen when we plot it, not, we won't mess with this offset beforehand, so we don't have to worry about it. We can kind of treat the game area as its own little coordinate system, and we don't have to worry about where it is or anything. We just kind of, so yeah, this is gonna be cool. So this the game area is going to have its own coordinate system. We need to store the x values and the y values now. So, yeah. So let's start. So we're assuming it's 11 wide. Let's start at about 4. Let's do 4, 5, 6, 6. So that we're going to have an L piece, I guess. So, the Y, I think, no, yes, it goes to from 0 to 12, I think. I might have this wrong. Is this? Let's just try it. Let's see what happens. Oh, I have to draw this every time, don't I? I might add a thing that makes it so we don't have to... Cool. It's way more to the right than what I thought I was doing, but that's cool, I guess. Why is it to the right? That's kind of weird. At least the Y is correct. I didn't know the X would be wrong, though. That's weird. Oh, you know what I should do? I know what I should do. Okay. So this is what I'm gonna do. So I'm gonna So this is what I'm gonna do. I'm gonna say if 0, then and then I'll only do this stuff up here if I need to. And then I'm going to say else. And what this is going to do, so here, I'm going to store it. Store pick. Else. Oops. Right? No, and I'm going to say if theta equals, I don't know, pi, then we'll do this. No, if theta doesn't equal pi, we do this. Okay? But as soon as we do it, we're going to set theta to pi. We're going to store the pick as 1, I guess. And then we're going to set pi into theta. And then if pi happens to be theta, then we'll just assume that we stored it. And I know I said I don't want to like let the program depend on other stuff. But like at least for debugging, we should do this because it's going to take forever to like recalculate everything. Okay. How do I? Oh my goodness! I hate when I press when I quit out of the program. I want to recall the picture. How do I do that? Draw, I guess. Yeah, recall pick 1. Yeah, so now when I run it, it'll have to draw it like this, right? But then as soon as I run it again, it won't have to draw all that, is the idea. So let's run it again. Bam, see? It was faster because it just recalled the picture. I don't know why those are white, but they shouldn't be, I think. That's weird. Oh, because I didn't put a C. Why didn't I put a C? Of course they're going to be white. Anyway, yeah, now they'll be whatever color. Anyway, okay, moving on. So, let's see here. How are we looking on batteries for the not the calculator, but our camera? We drawing the thing, but I'm offsetting the Z or the X by 5. Right. What was I thinking? I don't need to offset it actually. Yeah. Yeah, I don't need to offset it. What was I thinking? Huh. Okay, so anyway, that's a piece right there. Now we should just make it, I guess, fall. By well, we need to erase it, is the problem. But you know, here, this is an very interesting thing right here. They have an erase number. What is an erase? Are you serious? Like, what's an erase? How do you use an erase number? Is there like an erase function? It would be nice to erase it. If possible. Because that would be fast, I think. How do you... line, horizontal, vertical. Yeah, I don't... Maybe what we should do is we should take a picture every time we place the pieces. And then whenever we want to move the piece, we just replace the picture. No, I think that would take too long. But yeah, I don't know how to do erase. That's kind of interesting that it has an erase number. Because how do you erase it then? There's erase number. Like, should I try to give it an erase number and see what happens? I don't know. It's kind of weird. Like, what if I give this one, like, what if I, here, like, I give this, like, erase number, like, 5 or something? You know? I gave them erase number 5s, so is there a way for me to erase them? I don't know, it's weird. Like, how do I... I wish quitting out of something didn't quit the program, but it just quit the menu. I guess I need to pick clear or something. I don't know. I don't know what I'm doing. Draw inverse color. Huh. Yeah, there's no...
I don't know. There's no... Clear draw has no arguments. So how do you... So how do you delete... What's erase number? I really don't get what erase number is. And I can't Google it right now. I don't even have an internet on me right now. Yeah. Where's erase number? What is that? I don't even... We should use it, but because otherwise, I don't know what to... Like, I guess I could draw over it with black. I mean, I don't really know how else to do it. I'd rather not. I'd rather just erase. That seems way faster. I don't know. This... I wish this calculator had better like passing functions, you know. I mean, it's not even the structure of the algebraic structure of the code's not even a complete system, not even Turing complete, and it's just not a good not a good programming language. Why is there no explanation for erase? There is no explanation. I can't erase, can I? I can't erase because I don't know how to, or because they never implemented it. But I don't know right now which of those is true. So, let's move on. Let's do a loop here. We already picked our color. We already picked our starting coordinates. So we need a loop. We're just going to while one like we usually do. And then we're going to add to the coordinates of the y. So let's see here. I guess what I should do, technically, is save the old coordinates and erase those first when I do this. Which means I'm going to have to write out the lines again. But that's okay. I'll just I'll do it. I don't mind. I'll do it. But those should be the last line statements I will have to write. For A is 1 to 4. Let's see here. What am I doing? I'm really tired. I have a test tomorrow morning. I'm doing this because it calms me down. Believe it or not. Okay. For A is 1 to 4. What was I going to do? I forgot what I was going to do. Alright, we're going to increment the coordinates. So we're going to add 1 to each L5. Subtract 1, I mean. Yep. There we go. Okay. Now we can erase the old one by storing the... Let's just get rid of Z. Z is stupid. I don't know why I even put it in there. Or why I made that mistake. But yeah, let's just get rid of that stupid Z thing. I don't want to use it. I don't even think I'm planning to. We'll just keep. Yeah. Okay. So. Come on here. So we're gonna update. We're gonna update L5 in some way or another. It's not necessarily going to be just moving it down. It's going to be some way or another. But when we do, whenever we need to draw the new thing, we need to erase the old one. Which means we need to draw the old one, right? So this is going to seem weird, but like I'm going to store them. I don't want to use more lists like that though. I should have used L3 and L4 because then I can use L5 and L6. You know, I'm going to use L3 and L6. So L5 is going to go into L6, and then L4 is going to go into L3. So 5 is going to go up, 4 is going to go down. Yeah. And you know what? Let's just do that at the start of the loop. So that when we change them, yeah, we can just plot L6, L3, L6. So we're just going to copy. Oh my goodness, there's a Z. We're just going to copy it here. So we're just going to do the exact same thing as we see below. And I wish I didn't have to do this, but I do, I guess. But we do have to have both of them in memory, so we would definitely have to have like 4 lists, so, but whatever. L3 of A, comma, L6 of A, comma, L3 of A plus O, comma, L6 of A, C. Okay. Again, L3 of A plus O, comma, L6 of A, comma, L3 of A plus O, comma, L6 of A, comma, C. Or not C, but black. Okay, I'm gonna put 0 because I'm not sure, but I think we'll see. Anyway, so L3 of A, comma, or plus O, comma, L6 of A, no, A plus O, comma, L3 of A, comma, L6 of A plus O. And last but not least, L3 of A, comma, L6 of A, comma, plus 0, O, L3 of A, comma, and L6 of A. No. And then, I guess, 0 at the end of these. Let's just see if our coordinates and stuff got right. It looks like it is the right color. I think I screwed up a couple coordinates though. So let's enumerate this a little bit. So we got none, none. We got OO on off. First line OO on off. 3 6 3 6. 3 6 3 6 3 6 3 6 3 6 3 6. It should be OO on off on off, and then on off on. Why is it on off on off? Should be on off on off on, and then on off on, and then off on off off. Yeah, so that should work. Cool. Okay, so it takes forever to draw, which is kind of depressing. But yeah, I guess it kind of works. Cool. So we do have something that kind of looks Tetris-y. It's just really slow. But it's like the best I can do. I wanted color. Like, I thought it would be so cool to make Tetris in color, and yet I'm just so mad that I can't do that. And it's depressing that I can't do it that fast, you know. But yeah, now we can mess with the coordinates however we want. We can rotate and whatever, and it'll erase the old one. Yeah. Okay, so now what we need to do is we need to see if any of the y's are less than 0. Right? Right? We need to see if any of the y's are less than 0. So I'm going to have a t, like test equals 1. Right? And I'm just going to set it to 0. I'm just going to set it to 0 if the y's, if any of the y's, so I'm going to do a for loop again. Okay. And I'm going to say if y I'm trying to think, because if we're not able to move down, that's like the main thing. So, like, there's multiple conditions that allow us to move down, and one of them, and if this is where we're moving, then that's where the test actually has to be. So actually we need to test here, because when we test to see if we're intersecting something else later on, it'll have to be here. So, yeah. For A is 1 to 4. Give me a second here. I need to... Yeah, my phone kept vibrating, and I think I just needed to mute a group me, because people like to keep messaging on that group me. So anyway, let's see here. And by mute, I don't mean sending it to the group me. I mean my phone doesn't notify me when there's... So what I want to do is I want to check to see if they're less than 0. Or no. Sorry. This, I have to check post movement, right? Because the idea is that if I can't move, then I don't move. Then I set my old coordinates back. That's the idea. So test would become 0 or whatever, something like that. For A is 1 to 4. If L5, sorry, L5 I think is the Y, is less than 0, then we're going to store 0 into T. And my head is starting to hurt because I think I've been up too much. Too late. And it shouldn't have kept going. I don't know what was L5. Very negative numbers there. Yeah, I don't know. Oh, here. While T. Okay, and then I'll have a while 1 out here, because this is where we get new pieces. Right? There we go. So this piece should kind of hit the ground somewhere, and then we should get another piece. Good. Kind of worked, I guess. Yep. Okay, so to make sure that it works properly, there's another thing I forgot to do, which is I actually need to, since we're basically forced to draw it again, which I should be drawing it at the start only, not at the end, because we can't. Or you know what? Oh. I could do an if statement actually, and just not draw it instead of setting the old coordinates back. That's probably the right way to do it. So if t, or that's probably the way to handle what the code that I have set up right now. So if t, then we do this end part. That's probably a smarter way to do that. So now our piece should fall properly. It looks weird because we're erasing in most of the time, so oh no, we're missing a piece. Huh. Okay. Anyway, jeez, I don't even know what's going on. Why is it missing a piece? There should be 4 pieces. A is 1 to 4. 4, 5, 6, 6, 12, 12, 12, 11. Those all are different coordinates. I don't know. Yeah, I don't know why. One to 4 is 4. I mean, we did plot 4 the first time we drew it too. That's why I'm confused. Like, why is there only 3? Oh, because we're erasing. No, it shouldn't matter. We're erasing first. And then we're drawing. Every single time we do that. So I don't know what the deal is. I don't know why there was just 3 pieces at the end. It's kind of weird. L4 and L5. Yeah, those all have different coordinates. So what? I don't know. Really, I don't know. We can start doing the matrix thing now though. So basically, well, let's do movement first. Let's move left and right, and then we'll do the matrix thing. So we should be able to move left and right if we press the right keys. So, and we're only going to allow one movement at a time for a. Okay, I'm going to do a for loop with 10 loops in it, and it'll allow us move 10 times for each thing. So we're going to have get key store as G, and then we're going to say And then we're gonna say if get key, if G equals, let's see, I'm wondering if it's the same. But 24 and 26 should give us moving left and moving right. So 24 we should be able to subtract from x. So -1 stores, I guess we'll just store it as x. I mean, I don't know. So then for each one of these, so then we can say if x, because we want 0 to be an x before this. But for each one of these, we can just go through and add to L4 what x is. See? And there is 4 pieces. It's kind of weird that they're drawing like, I don't get that. It's so weird. Of course, we shouldn't be able to go out of bounds. And it should draw maybe every time. I don't know. Why is it not drawing all of them? That's not cool. I want to like, here, I'm gonna run it. Okay, so I'm gonna quit and I'm just gonna look at the thing. So L4 and L5, those look okay. Okay, I'm gonna check L3 and L6. Yeah, that's why? Why? Oh why? Oh why? You know what? It might be the thickness of the line or something weird like that. I mean, okay, what happens if you draw over what's already there with zeros? You know? Like, what happens? I guess I don't know. I guess this will have to be, I'm just too tired to work on this, but this will have to be, I guess, part 1. I didn't know I was going to do multiple parts. I kind of felt like I was going to do Tetris all in one go or something, but I before I even started recording, I spent a while. It's already past midnight and I have a test and I still have to fix some homework before my morning class, and also my test is in the morning. And I'm like too frustrated to I'm kind of frustrated at the fact that I can't draw colored, like I just can't output colored characters. And there's no way to just draw a box on the draw screen that's a colored box. Like, if I could do that, then characters wouldn't be a big deal. I could use boxes or something, but I can't do that. Like, I have to draw my own square using lines, and that is not cool. And then there's not even a good way to erase them apparently. Like this is so ridiculous. It it drives me crazy. This is something that you should be able to do. This is something you should be able to control as a user. I mean, math isn't just about plotting, y equals x squared. Okay? That's not what math is just about. I mean, look at Wolfram's research and you'll realize that that stuff is actually simpler and more base in more of a basis for the fundamentals of nature probably than some of the silly stuff we do. So I just think, I mean, we should have control. We have control over some pixels, but we should have control over the machine a little more. Anyway, this has been Calculator Programming with Tim. This feels like such a downer episode, but we're trying to do Tetris. It's hard. It's there's doesn't seem like a good way to do it. If you have suggestions, please let me know. Please just think of something that's better than what I'm doing. Try it out first though, but I wish there's something that just worked. We could do characters. We could switch back and we could just say, screw it. We're going to use characters. It's just going to be in black and white. I could do that. I've done it. I've actually made Tetris before on a TI, I think 83 or 84. And it was in characters and it worked okay. So, anyway. See you guys. Ooh, you can see my reflect. Wow. You can see my reflection. So can you see me when I'm standing up? Oh, you can see my reflection in the calculator screen. That's crazy. You can see the camera. See you guys later. Okay, welcome back, guys. Part 2. Okay. Trying to calm down. I am someone who gets angry very easily at things, I think. Anyway, I didn't really do much with this program. I just kind of was looking at it in the last like 5 minutes or so, and I noticed that I realized actually right away after playing around with the test that actually I know what I was doing wrong is kind of silly. So I added a pause here to see why like one of the boxes were blacking out, and then I realized that actually what I'm doing here is I'm drawing a box or I'm erasing one of the boxes and then I'm drawing another box, but then I'm erasing another box, and so what ends up happening is I'm erasing one of the boxes that I just drew. I actually need to separate the for loop into 2 for loops. And by the way, I put 12 here because 12 is the color for black. I don't know if it matters because I think 0 is also black, so I don't know. So this, I'm guessing this should work. Then, yeah, here we go. So now that's like how long it takes pretty much for, I mean, it's going through a couple other loops, but watch when it starts drawing and when it stops drawing. Like, that takes a while, it seems like, which is kind of sad, but yeah, it's kind of slow, isn't it? It's kind of cool that it's colored though, and it looks like Tetris, which is cool. And I just went out of bounds, which I still have to fix, and I just went through another piece, which I still have to fix. But yeah, that's pretty interesting. Now, adding more stuff to it shouldn't really make it much slower, I don't think, because it's all going to be internal stuff, and it's going to be way faster than what drawing it really takes. So this is going to be similar to what the actual speed of the game is going to be, I think. Yeah, it's so slow though. And you have to redraw each one. I wish there was a way for me. Hold on a second. For some reason my camera. You know, you gotta love lithium batteries. You gotta love them. You gotta love lithium. You gotta take care of it, maintain it, not charge it too much, but then make sure you charge it enough. I wish they came with it. I wish all batteries had like a special chip in them, which carefully, just whenever you kept your device plugged in, it just carefully managed it wouldn't charge it too much, and it wouldn't charge it too little, and it would just pretend it was at 100% when really it was at 100% of what you should keep it at, or something like that. And then you can maybe have an option to overcharge it if you know for a fact that you're going on a trip or something. But like, come on, like, anyway. But yeah, it looks like we can definitely keep just dropping pieces here forever and never lose the game because they'd never stack up, which is lovely. So next, I'm thinking maybe just doing stacking because I don't want to think about rotating yet. So let's just do that, I guess. Yeah, this is slow. I'm sorry. I wish it wasn't. So yeah. Let's just go ahead and do stacking, I guess. So here we're subtracting from the values, and then we see if a is less than 0, and we have to check other things. So we have to actually check to see if. Hold on a second. I need to close my door. We actually need to check to see if the matrix, we're going to use a matrix. Okay. Yeah. We're going to use a matrix. I need to use a matrix. Let's go ahead and instantiate that wherever we need to. I'm not sure where. I guess right here, because it's going to be above the loop at which we makes us fall, obviously. And it's even going to be above the new game loop, whatever that is. So but it can be under this one because that's just the background. So the background, maybe. Can it? Or do we need to redraw the background after each game? It doesn't really matter because I'm not putting it inside the loop is the main thing. Because no matter what, we at least, how should I say this? We at least will need to reset the matrix if we set the background, but not the other way around. Does that make sense? I guess that makes sense. So let's go ahead and set the dimensions of matrix A. So we're going to set it to 10 by, or no, not 10 by 25. How many wide was this? Wasn't it 11? Or we're doing Y's first, right? So we're, oh my goodness, I don't even remember. 12 tall, I think. Is it 12 tall? For Y is 0 to 12. That's 13 tall. Wait. 0 to 12. Right, so 13 tall and 11 wide, I believe, is what we're going for. I think. If I remember, if I'm doing this correctly. I think that's the size of what we have to play with. Yeah. So we're not going to, let's do walls after this. Let's just make sure we can stack it. Forget about walls. 13 by 11. Yeah, because walls won't add anything. I want to see something cool that we added. Adding walls won't add any interesting looks. It'll just prevent us from making something that looks weird, which is going outside the wall. Okay, I think I want to fill So I'm going to go into matrix menu. I'm going to fill matrix, well, matrix A with zeros. I think I need to pass 0, comma matrix A. I always get this wrong. I should have hit the plus this time. That's probably what the plus is for. You know. So let's just verify that this is the right height. It should be 13 tall. By the way, this is a Cutco knife. I use it to chop all my vegetables, and yet it's literally supposed to just be a butter knife. Yeah. Long story short, I sold for them for a while. But anyway, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's 13. And it looks like we got 3 here, 4, 5, 6. And then yeah, 13 wide. Or wait, what? Yeah, 11 wide, 13 tall. I think I was correct. But we will, the way we access the x's is going to be different, or the y's and the x's, because I think we're starting with at 0 for both the y's and the x's. I think. Although no, because the x's we might be starting at 1 actually, because we have 5. Because -4 through 0 actually are the walls. So I think x's are going to start at 1, y's are going to start at 0. So we're going to have to do the y's differently, I think. Yeah. So, how do we do this? How do we do this? What are we doing? We don't need to go up here. So we set them, we fill it with zeros, and then whenever we stop, we need to find, we need to check right? And you know what? Let's make the x's, let's make it 1 taller. So that this will save us some code, I guess, if we make the matrix 1 taller. Because then we won't have the bug of like checking to see if we're like outside the range. Well, I guess it doesn't matter. Or, even better, if L5 of A is less than 0. Let's get rid of this altogether, that statement, and let's do something extra. What we're going to do is we're going to add an invisible wall underneath, and that will save us some code. So instead of 13, we're going to make it 14 tall, and then we're going to for loop for A is 1 to 11, and we're going to set 1 in the matrix A's 14th row, and then A, 8th column. And what that will do is that'll give us an invisible wall at the bottom. And so instead of us checking to see if we're less than whatever, we're just gonna then it makes it simpler. We can just check if we're going. We can just check if we're going down. And in fact, we can actually do this with the sidewalls too, come to think of it. That'll make things a lot easier, I think. Because, yeah, that'll make things easier. And then what we'll do is, because otherwise someone can just press on the side wall, and what will happen is there will be a bug where they can just like stop on the side wall or something, which of course is going to be wrong. Um, but we're not going to let someone change it unless the values are correct. But here we have to make sure that the values are correct in order to continue incrementing, I guess. Yeah, so in order to change the values, they have to be valid. But as soon as we force the change, as soon as we reach this point of the code before we draw it, that's where we check to see if no matter what, if even the previous, even if the y incremented doesn't make sense. So yeah, the y increment should make sense, but before we do the y increment, we should have a chance to move things left and right, which also need to make sense before we even do the y incrementing. So yeah, sounds confusing, but I guess that's what needs to go on. So yeah, I'm going to delete this line, or I'm going to replace it with something else. So I'm going to check through all of them, and I'm going to say if L5 of A, instead of that, I'm going to say if the matrix A of so 4 is X, right? So that's our Y. Right. So of that, comma, L4 of A equals 1, then 0 stores T. Ooh, that's actually really simple. That's like one line for loop, which is crazy. So basically this piece should fall and then it should stop at the bottom, hopefully in the right place. Oh. That's weird. Our L5 should be our Y, and our Y should be 14. Why would it be invalid dimensions? Let's see, L4, L5. Right. No, I don't see ones when there should be ones. Why aren't there ones? There should be ones. There should be ones in the matrix. Why aren't there ones? For A it's 1 to 11. 1 stores matrix A, 14 A. What? There should be ones at the bottom. Anyway, basically what was happening is, although it didn't reach the bottom, so why were there zeros? It's like it was trying to get a new piece too. But I think, oh no, that does make sense. So it stopped before it hit the bottom, I think. And then it also tried to access something too tall in the matrix. So I have to subtract 1 from Y, I think. Or add 1, sorry, I have to add 1 to this number to get the matrix index. Because it's a 1, it's not a 0 base number. So let's try this again. And hopefully it reaches the bottom. I don't know if it was actually at the bottom last time, which is weird. Huh. Okay, reach the bottom. What? -1. Wait. What? Why is it -1? 1 for the Okay, when it's falling down, the L5 is getting smaller. Right. Oh. Right. There should be a 1. This should be stored at 1, I think. Good, it's falling. Okay, so I think what happened was there was a row of 1s maybe at the top instead of the bottom. Although that... Why is it doing that? That's weird. Huh. The bottom... Okay, see how that top row is 1s? That's good. So that's basically upside down from the actual like game, which is kind of annoying, but that's because anyway, it doesn't really matter too much, I guess. If you just flip it in your head, I guess we can deal with the inversion, but the I don't know why I'm getting text messages a lot. Sorry, my phone, it took me like 5 minutes to scroll up because I have an Android. Anyway, okay. Okay, let's see, how do we do this? 14, 11. For A is 1 to 11. Why? Why is this? Because when I draw them, Y goes from 0, right? 0 to 12. So 1 to 13 in this case. 14 would be the floor under the ground. So I should be adding 1 to the coordinates. It shouldn't be 1 above the floor. That's weird. Right? Because I'm not drawing it if t is 0. I'm not drawing if it... Well... Okay, so what we're going to do is if not t, or what we could do is we can just put it in an else down here, which is kind of annoying because it's so much... let's see, so if t then 4... and 4, and then I guess I can put an else here. So if t is not true, then I can store 1 into the matrix. Elf 5a plus 1, elf 4 of a. No, that's wrong. That's if I didn't move it. Right? Which means L3 and L6. I think. Okay, so then once this piece is stable, we'll see if it actually is stored in the right spot. Why is it invalid dimensions? L6 of a plus 1. Well, what's L6 of a? Well, what's a? Wait, what? A is 5. What? That's strange. Did I pay? Right. Oh, I need to put a for loop here. There we go. Okay, so that particular issue shouldn't happen, but if it crashes again when it lands, I'm guessing it's a matrix error, which is still, I'm still trying to figure out how that... Okay, so that piece should be saved. Let's look at the matrix. Yeah, it looks like it's sitting on top like it should be. Right? Oh! I totally didn't realize. I didn't think about this for some reason when I switched it. But when you, okay, because we're doing it 14, because we're filling the first row with 1s, that makes things more complicated because things are falling up in the matrix, right? And there's no 0. So this matrix actually has to be a 2-based instead of a 1-based. So it's not 0-based, it's not even 1-based, it's a 2-based. Which means, but I mean, we already added a row, which is fine. But that just means whenever we need to access it, we actually have to add 2 to it each time. So I actually have to add 2 to this. Every time we use it, we have to add 2 to the y. We might have to do that with the x's, which is fine. We'll have to add 1 to the x's, maybe, in the near future. And that's just so that we add some walls or whatever, which would be cool. So now it's landing on the ground. Things are all happily doodly. Of course, we don't know if things are working perfectly unless we look at the matrix, of course. In which case, yes, they are sitting on the top of the matrix because that's when they stop. So yeah, cool. Shoot, let's... I guess we could either add the walls or we could put a check for if things are in bounds. Not sure which one we should do. All the pieces are solid, which means that pieces don't have floating pieces, which means that if we put a wall, it will strictly work perfectly, and we won't be able to go through the wall or anything weird like that. So we could do it, we could make it wall-based, so why not? Why not? Why not? Why not? We can. Let's do it. It's fine. Let's do it. Let's make this 13. Okay. This doesn't have to be 13, but we'll make it 13 just to make things simpler. And then let's just do a whole nother loop. For A is 1 to 14. And then 1 stores matrix A. And 1 stores matrix A. And then we're going to do A. And then 1 and 14. Okay. And then we're going to add 1 to every time we use the matrix, we're going to add 1 to the x value. As long as we just have a standard what we add or subtract to the x and y value, that things will be fine. So now when we run it, why is this doing something? 1, 13, I think. Did that wrong. Okay, so now what should happen is this should be in the corner and it should be surrounded by 1, so there should be a 2 box gap where there's zeros. Let's go to the matrix and check that out. Yes, there is. It worked. Everything's nice and pretty. Cool. So now we don't have to check for walls. We don't have to check for the floor. We don't have to check for anything but the matrix now. That is the only thing we have to check for. That is the only thing that we have to worry about it. We are now surrounded by the matrix. The matrix is all around us. It is everywhere you look, everywhere you see. Anyway, so yeah, this is cool. But now we have to do something interesting here, because basically what we have to do is until we move down, we don't force. But this is the confusing part. Like, I would like to, right here in this loop, be able to move left and right, but the problem with that is we don't get to see ourselves moving left and right. You get what I'm saying? Like, we basically are doing it internally. We don't see it until we actually move down. When we move down, then it's like, oh, I moved left like 5 times. It's like, what? That's weird, you know? But I don't want to put more line commands. Like, I actually just want to use these ones down here because they're so long and obnoxious. So what I'm thinking is to treat this loop in a special kind of way where essentially most of the times through this loop, we redraw the piece if needed. We basically, if we move, I'm not sure the best way to do this, but basically what I was thinking was, if we move, then we should redraw the. If we move laterally, we should redraw the piece. Which means basically we finish the loop and we only draw it if we need to. But we actually do the loop like 10 times or 5 times or something. So that gives us, like, we can move 5 times if we really want to per like vertical shift. but we shouldn't redraw it just 5 times when it's in place, because then that would just look silly. And yeah, so I'm thinking of using, I might have to use more than just this t as a 1 and 0. I might have to have more control flow variable power here. So essentially, this loop could be doing one of two things. It could be moving down, or right. Okay. Oh, let me think for a second. Okay, so we can save the old coordinate. Well, we can save the old coordinates each time. That's fine. When we get the new coordinates, we need to check if we're moving, if they're valid. If they are and we're not moving down, then we should just redraw ourselves. If we aren't if we're trying to move, well, okay, no matter what the case is, whether we move down, if we move at all, we are both going to redraw, and well, actually, yeah, we are going to redraw well, no, because we could be on our last iteration where we move and it's a valid move, but when we move down, it's invalid, which actually invalidates our move if we combine them. This is it depends on how I want to design it, but basically what I'm trying to do is minimize the ugliness and the damage control on how much code we have to manage. Because I don't want to rewrite all this line stuff, but I also don't want to make it strange. I also want it to work correctly. And I don't want to do too much like copying and strength stuff that's going to slow it down. So we save the old coordinates here. And then we loop through 10 times. But the loop just goes to here, which is a little too short. What I should do is I should include... Okay, so what I'm going to do is I'm going to say I'm going to loop through this entire thing, but it's not going to loop, it's not going to try to push you down 10 times. It's only going to do that if b is 10. See, so if b is 10, then it tries to push you down. But actually I should include the drawing in the B, but only draw if your coordinates have changed. Right? So I need to keep track of whether your coordinates have changed. This is so confusing. While t or b is less than 10, I guess, would be this thing. I mean, no, that's wrong. Because, right, the for loop is going to contain everything pretty much. I don't get... Okay, I think... Essentially what you're going to do is you're going to try to move. So either x will change or b will be 10. So I'm going to look at the flags for that. So like basically I'm just going to say if okay, I need to extend the for loop down here. So for if and if then if t then blah 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 else do this and end. I guess I add another end. But this is the thing, like, this... Why are there two ends? This loop right here, that checks for whether we're in the thing, or that checks to see whether we've, like, stopped, that's not going to be here, because that's not going to happen every time we don't draw ourselves anymore. That's going to happen, like, outside of this. So I'm going to have to, like, insert 3 ends here. And then, like, delete 3 ends here. Or something. I'm trying to... There's too many ends. But basically, I want to do this loop when I know that I'm trying to move down. Not when... And that I know that I failed... Hold on. So if t equals 0, then we do this. Right? Because that then we know we've this is so many lines. Okay, is there like a loop? Right. There is a loop up here. So that does make sense. So there should be 2 loops. There should be 2 ends after that. Whew. This is confusing. Good. There should be 3 ends here because this is the while 1, this is the while t. This is this for loop. No, it's not. Darn it. I need another end. Okay. While 1, while t, this is the end, this is of the if, this is the end of the for loop. This, there's 4 ends here. Should it be 4 ends? I don't know. For that one, that's 1, 2, I'm not convinced. I'm not convinced that there should be 4 ends here. Because this, when this happens, There should actually just be the end for starting here. So if t, then, so that's one end. Then 4 blah blah blah. And then 4. That's 2 ends. So there should be 2 ends here. Yep. No, there should be 3. Because then the third end is this B. While B, no, not that one. While B, for B is 1 to 10. Okay, so basically what's going on is we're looping through the, okay, so the outermost one is basically says that, okay, we got a new piece. That's what this while one is. Or it's a new game. This represents which, like, we're looping through, we're adding new pieces. This while t is for loops once for each piece. Or did I say that? Is that right? While t. Yeah. No. It keeps looping. It loops once per each, like, the piece as it moves down. This loops per piece up here. Because, see, it gets a new piece. See, it says random R, like R, C, whatever. This while one is loops once per piece. This while t loops once per each the piece moving down. This while for B loops once for like each each chance you have to move left or right. And during its last iteration, is it specifically when we handle some stuff involving trying to move the piece downwards. In which case, if we can't, okay, you know what? There's a problem here because then I can cheat, and basically if I'm trying to move to the, for example, with how the code is set up right now, I could essentially have a piece that's diagonally sitting on top of another piece, even though it's not directly on top, because I tried to move it laterally while it tried to move down, and then it sensed that it was invalid, and therefore it couldn't move down, and therefore it saves its old position, which is floating in midair, which is bad. So I should not be able to move it left and right if, actually at all, if B is 10. You know what? This is what's difficult about it. I'm trying to get to these lines and get these lines used. Okay, this one I know for a fact I'm done with the B loop. But these ones, I want to redraw it